you know, just have fun with it. There's a website called Thingiverse, and on Thingiverse, people just upload their own 3D models, so it's in the form of an STL. You can see people upload some really cool things. Like there's an entire 3D printed camera available for download. So yeah, that's pretty cool. So if you want to download these kinds of objects, you would click download this thing. You'll see this dialog box pop up, and it'll have a list of all the parts. So this print is many parts that you would have to assemble afterwards. Some prints are just one part, or most prints are just one part. This is an exception since it's so detailed.
Complex.
But if you were to print this, you would be looking for STL. So you can see at the end here it says .stl.
And that's the format.
And that's the format that you need to 3D print. You can't just open any old 3D model. It needs to be an STL. And more recently, I think MakerWare, which I'll talk about later maybe, can also take OBJs, which is like an object file, which is another type of 3D model. But anyways, you can't use things like .blend files, which is a Blender file, which is made in Blender. So just make sure it's STL.
Is there a conversion software?
Yeah, I'm sure there's conversion software out there. Actually, with a Blender file, you can actually just open in Blender and export as an STL because that's just natively part of Blender. But I'm sure you can find software out there.
Okay.
So we're going to just click on the file here, and ask you to save it. You can save it to wherever you want. We have a folder for Thingiverse downloads, so we'll save it there. On Macs, you can just click to open it, so it'll open here. On PCs, because STLs are associated with certificate files on like the Windows system, you're going to need to go G. You need to go File Open, and then find it wherever it is, and then open it that way. Once you open it, it'll pop up here. And then also, if you're interested in 3D modeling instead of downloading your models, there's software called SketchUp, which is free. You can learn that on your own. Blender is also free, although it's slightly more, or it's actually decently more complicated than SketchUp, but SketchUp's a really good starting software.
Yeah, I've played with it.
Yeah. So next, in Replicator G, in order to print, first we need to connect to the printer. So, well, first you want to make sure the printer's turned on. Right now it's on. And you can see if it's red up here, it means you're not connected. It'll also say specifically that you're not connected, but just red in general means you're not connected. In order to connect, what we need to do is first go to machine, then machine type, and we want to make sure that we're on the proper machine. So this is the Replicator 2, it says so here. It's labeled on the printer. Not the Replicator 2X, the 2X would have 2 extruders. It also says 2X. So we have Replicator 2 selected, that's correct. Next we'll go to connection serial port. On Macs it'll say /div/tty, and then USB modem with some number. On PCs it's usually COM7 or COM3 in all caps. So we'll just select this. We'll go back and make sure it's selected. Now that it's selected, I can hit this button here, which is connect, and this should turn green. If this happens, so it says it's already in use. Right now, I actually didn't notice that MakerWare is running. So right now, this is like it's the equivalent of Replicator G, made by MakerBot, the company that makes these printers. And it's still in beta, so we don't discuss it as much as Replicator G, which is more reliable. But right now, since it's running, it's actually using the port that's connecting to the printer. So what we need to do is go to Services and stop the background service first. And once it does that, it stops like using the port. And then we can just close the software. I'll just close it without saving. Now I should be able to connect. So you can see now it stopped using the port. Now I can get through to the port. So now you can see I get temperatures and it's green and it says I'm connected to whatever port you connected on. So yeah, once we do that, I'll just go over all these options here. So you can't really 3D model in Replicator G, but you can manipulate your models to make it easier to print. So you can see I've got all these options here. I'll just talk about it. Actually, before I even talk about that, let me just mention this area that you're looking at here. So when you open your STL, you'll see the 3D model loaded into the center usually. Sometimes it'll be floating out in nowhere where like you won't see it, which I'll explain a bit how to fix that. But this is the equivalent of the platform here. So each square is 10 millimeters by 10 millimeters. And well, yeah, it's just 10 millimeters by 10 millimeters. And then this height here is just equivalent to the print area you have. So it's from it's from the platform to the extruder, not like from the bottom of the machine to the top of the machine. So then once you have it loaded, you can do some things in view. So in view mode, if you click on view, and then you left click in this viewing window here, you can rotate your camera around. And move, if you left click and drag, you'll move your model, and then it'll rotate, it'll rotate it. So every time you left click one of these things, the function of your left click changes. That's just nice to know. When you go into move, you can just click and drag, and I'll go into more detail about that in a second. So first in view, you have some default views. So this is just called the default view. This is just from the front at a slight angle. Then you have a top view, a side view, and a front view. You don't really need to pay attention to the axes here, but it's just saying like top in terms of like planes. But the use of these are, if you look from the front here, and then you look at the back, there's no noticeable difference between the front and the back of the platform, so you can't tell which way you're looking at it from. This is important when you start moving it, which I'll explain what I'm doing in a second, but if I were to move my model, right now from the back, it looks like it's on the left of the platform. If I were to go to default view, I actually see that it's on the right. Now, if you look at the platform here, right now it's pretty messy, which will replace tape later. But for example, if you were to print on this, this is more relevant for the Replicator 1, where the tape usually has bubbles or scratches in it, because this is easily replaceable. But if you have bubbles or scratches or marks like this, you'd want to avoid it by moving your model. So if you were to print on scuffs like this, it'll leave a visible imprint on your model, and it might be harder for the print to stick, especially on the Replicator 1. So then you move it. Now, if you weren't in the default view and you thought it was actually on the left, it would be on the right, and then you might put it onto a scuff and you might waste more time, that kind of thing. So that's when default view comes in handy. You can also just use the top view for just relative, like finding out position and stuff. So that's how I use view mode. Next is move. So this will just let you move your model around. So you see these buttons here. The x-axis is from left to right, y is from front to back, so like this way, and then z-axis is up and down. So this number here is in millimeters, so it's saying 10 millimeters, and whenever I hit one of these buttons, it's moving it like 10 millimeters in the positive x direction or 10 millimeters in the negative x direction. So that's essentially side to side, so you can see it hopping one square at a time, because those are 10 millimeters by 10 millimeters. And then also this button here, center, will just move your model to the center of the platform. And also if your model is like, let's say off to the side and floating, put on platform will just put it on the platform but keep it where it was in space, just set the height equal to 0. If it's floating and you center it, it'll put it on the platform, then it'll move it to the center. So center does the same function as put on platform, but a little extra where it moves it into the center. Right. And then if you were to click and drag, which I don't really recommend, you'll see that it actually moves in all 3 dimensions. So it moved to the right, it moved back, and then it also moved up. And this is bad because if you were to try to print when the model is floating, then your extruder is just like in the middle of the air, it's just start extruding, and then nothing's going to happen. So if you want to click and drag to move it, which is probably the more convenient way, just make sure you lock the height so it can't leave the platform. Now you can click and drag it and it will stay on the platform. And then you can place it wherever you want instead of like mashing buttons like that. So that's how you would move your model around.
Okay. And basically the reason to move would be to
just avoid anything on the platform. But otherwise you can print wherever you want. If the tape were replaced, you could print wherever. Yeah. Gotcha. And then next is rotate. So in rotate, you can rotate your model around whichever axis. So for example, you have the z-axis, which is vertical. So if you have like a model like this, it rotates around the z-axis. So it's just like a hard concept to wrap your head around sometimes. Like x is sideways, so it rotates around like that. So you can see if I do z minus, it's just spinning it. And then x minus will flip it this way. But yeah, that's how you do this. It rotates in 90-degree increments. If you were to click and drag, it'll rotate it at some, just like a random angle, whichever you dragged it to. You don't want to print it like this, obviously, because right now half of my model is sticking through the platform. That won't print. And it's also at an angle, which means that as the plastic is extruding, if it's at an angle, if the angle is like steep enough, the plastic is probably just going to fall down because there's nothing below it. If the angles are generally gradual, then the plastic can actually layer on top of itself while slightly slanting over. But if it's too steep, then it's just like one layer isn't wide enough to support the layer above it. So that wouldn't work out very well. There's also a button here, lay flat, which sometimes corrects it. Actually, I'm surprised it corrected it there. A lot of the time it doesn't work, but yeah, sometimes it'll lay your model flat. Normally it shouldn't be an issue though, because most people that make models won't build the model at an angle. Usually they come in flat or on the side, and then you can just flip it. So normally this is an issue, but I also don't rely on lay flat because it normally doesn't work. Like I'm really surprised it worked there actually. Also, yeah.
Just to go back, so when a designer makes something, in all likelihood, is it in a position?
Yeah, that's good for printing. It should be flat or on its side, but it shouldn't be at some angle
Crazy
that's
angle.
not 90 degrees.
Yeah.
So, yeah. And then next you can, instead of clicking and dragging, which puts it at some weird angle, you can lock it to rotate around Z, which means you can only spin it, but at least this way you're not putting it at some
Changing
angle.
the angle. Right.
So that's that. The reason why you want to rotate an object is, let's say someone had built the object like this, where it comes in on its side. Obviously this wouldn't be optimal for printing because you have this single point along the cylinder that's going to hold up the entire model. So that's not really optimal because
Stable.
yeah, it might topple over and it just won't come out cleanly. So then you would use rotate to fix your model. Oops, like that. And then it would, generally what I tell people is you want the largest, flattest surface to be touching the platform. So this would be a flat surface. This is the only flat surface. And it's touching the platform, so that would be the best way to print it.
Okay.
So that's why you use rotate. That's that. Next is mirror. So what mirror does is rotate kind of moves your object so you can see it physically moving. So if it's here, it'll come here and it'll float, but it'll also move a little bit. When you go to mirror, it just flips it in place, so it doesn't move anywhere. It just flips it. Yeah, it just flips it in place.
Okay.
So right now, because this object is pretty symmetrical, yeah, you don't see much happen. I don't use this tool as much because it doesn't, unless you need to flip something over, it's fast for that. But you can also do that on rotate, however you want. That's reflect or mirror, whatever you want to call it. I generally don't use that often, but it's nice for flipping something on the other side if you want to. Next is scale. So the way scale works is it takes the dimensions of your object and it'll multiply it by whichever number you put in here. So if you're going to multiply by 1, multiplying any number by 1 is that same number again. So obviously if I do this, nothing's going to happen. But if I type in 2, it'll double the size. And then to reverse, you could just type in 0.5, for example, and it'll half the size after doubling it. So that's the way scaling works. It's not very precise. You could, I suppose you could go to a top view and count squares if you actually wanted a more precise dimension, but I can also talk about MakerWare, which will give you more accurate scaling. You can actually specify a size that you want a dimension to be, but I'll talk about it in a bit. Next are these two buttons here. What these do is, if you were to make a model in SketchUp, for example, when you export it as an STL, you would need a plugin because it's not native to SketchUp. It can't do that natively. But if you have a plugin, most of the time it asks you what dimension you want to export in. So let's say you built a model that's 5 inches. If you were to accidentally say millimeters instead of inches, it would replace the unit inches with millimeters. So now when you open the model, you have this 5 millimeter object when it should have been 5 inches. And then these buttons will correct the scaling. So like let's say this got scaled down to millimeters when it should be inches. This will fix it. Obviously if it's in the right dimension, then it blows it up to huge proportions. But normally if that problem were to happen, it would come like that where it's practically microscopic. So then that would fix it and put it back to normal. So that's what those buttons do. If you're planning on modeling in SketchUp, that'll be very useful to remember because I've actually ran into that problem a few times. So it's nice to know. Next is this one, fill build space. I don't recommend you use it, but I'm just explaining what it does. It scales your model up until it hits one of the boundaries. So I think it hit the X or Y boundary, so it went the furthest on the Y-axis that it could go. So it stopped it. Obviously, you won't want to print something like this. It'll take days.
Right.
So.
Now, I noticed that it didn't go to the top of the box. The top of the box is the last point the extruder head can
Yeah, that would be like where the extruder is. That's the highest the highest you can print something.
Gotcha.
Because since this is at a fixed height, it wouldn't be able to print any higher.
Okay.
Right. So that's scale. Once you make all your changes, so moving it and rotating it, however fits the platform, whatever you need for the print, then you can generate G-code. So G-code is just it takes your STL and it turns it into essentially coordinates and then commands that control the printer. So, I mean, yeah, what the printer does is when you get the G-code, it just reads like each coordinate point and it moves from coordinate point to coordinate point. Obviously, there's tons and tons of coordinates, and that's how it makes its object eventually. So that's what we're generating here. So this is kind of like a Word document. If I scale it and rotate it, and I save it, it'll be saved in that state, so I won't be able to undo any scaling I've done unless I remember like exactly how much I scaled it by.
Okay.
But yeah, so I'll just save it because I didn't make any changes to it, like any major changes to it, and then just wait for this to pop up. When this pops up, we can specify settings for the print itself. So first thing, slicing profile. This is just asking what printer are you on, so it knows like how to generate the G code for which machine. This is a replicator 2, so we'll just select replicator 2.
Gotcha.
Next is rafter support. This is kind of hard to explain verbally. Actually, maybe I can pull up some images for you. So if I look up 3D model, the 3D printing support material, maybe find some pictures because we ran out of we had some models with support material on it. So let's see. This is a pretty good example. It looks like that's a skull, but you can see on the sides here. Actually, you know, maybe I think this is a better example. So see this image here. You can see that's the model. I can't really tell what it is, but that's kind of irrelevant. All this scaffolding on the side, so you can see it actually it zigzags. It goes down and up and down and up like that. And you can see it prints like around the entire model. So it's kind of like a scaffolding for plastic. So the way it works is, let's say you had a model. Actually, I don't know. These aren't really good examples, but if you had any old
It's like
model,
a ping pong ball or something, it would make it more so it.
not necessarily for a
space?
ping pong ball, because a ping pong ball can actually be printed. But if it was something with more like a severe overhang, so like if it was just something like this with just something hanging off anything, because the way the printer works, it works from the ground up, and then layers plastic on top of itself. Once you get to anything that hangs over, there's
no
nothing
support.
below it, right? So when the plastic gets extruded, it just falls, and then it won't be printed. So what the support does is it makes a scaffolding around your model, and it builds it all the way up along with the model. So that's what you see here. Here's the model, and for every layer of the model, it also makes a layer of support until it gets to wherever the overhangs are. Once it gets to the overhangs, there's this thin layer of plastic that was built by the support that'll let that overhang be printed, because then that overhang just prints on top of this thin material, and then it can finish the rest of the build with overhangs. And it's made such that it's really easy to remove. So if you see how thin the walls are and the zigzagging structure, you can kind of just peel it off afterwards. And there might be some visible marks on your model, but generally you can maybe sand them off, something like that, clean it up, and it'll let you print your object. The only problem with support is that it'll take a lot longer to print, so you can just see how much extra plastic that is. It might be just as much plastic as the model itself, actually. So when you use support, generally what I do is I look for ways to maybe rotate the model so that I won't have to use as much support or any support at all. But if I need to, I guess I'll have to use it in order for it to print. Next is the raft. So you can actually see the raft here as well. The scaffolding here is called the support, but the raft is those few layers on the very bottom you see going all the way across. So this is also like a grid structure. It zigzags up and down one way, and then it goes in the other direction, so like across the grain, and that's what makes a raft. The raft we generally use, let's say you have a very thin model, so something that's only a few layers thick, that might be very wide. Because on these printers, plastic sticks very well, it would be really hard to take that print off using like whatever tools you have available. So what the raft helps with is getting that print off. So if you were to attach a raft to your model, you could actually get under the raft a lot easier, since you can see there's a lot of little bits that hang out. And because it's 2 layers with gaps in between, there's spots where you could probably put a tool under, where you could get like whatever print up, where you could get some leverage and peel the model off. So we use it like that. It's also necessary for support. It helps, like you can see how thin these layers are. It'll help support the support, so that the support has something to stick onto. So it's used in that way. You can't have a raft, you can't have a support without a raft. You can have a raft without a support, however, and you can also have neither.
Sure.
So if you wanted only a support, if you want only a raft, you would check this button. If you wanted a raft and a support, you could specify exterior full, which I'll explain in a second. And then if you wanted either, just uncheck both and set this to none. So if you wanted support, there's 2 things, there's exterior and full. The difference between the 2 is if you have exterior support, it's only on the outside of the model, so it's like only on the outside here. But let's say this model were some hollow cup, for example, or a glass of some sorts, or maybe like a Coke bottle, that kind of thing. If you had full support, even the hollow inside part of the bottle would be filled with plastic. So that's in case there's any overhangs on the inside of the bottle that would need support structure.
That came up and cut way in.
Right, yeah, and then it went back up. Then the support structure would help that part that overhangs on. Right, but the only problem is if it's a bottle, you can't really get it out, and it's no longer really a bottle because it's filled with plastic. But I mean, so normally I don't use full support if it's something like that. Usually model makers will understand that if they're putting it on Thingiverse for 3D printing, so usually they'll try to eliminate any overhangs like that. And I'll also explain object infill, which is kind of like a pseudo infill, but that's for solid models, so it's kind of different. But anyways, normally you would use exterior support unless you really need full support. So yeah. And then for this model, you wouldn't need any support or a raft because there's no overhangs really. And those small little points, so if I actually zoom in, those should be small enough and light enough that the printer can hopefully just move out a little bit and layer it. Although one problem I noticed is that this goes straight out instead of gradually angling upwards. If it angled upwards, then it could gradually start, moving out. But because it goes straight out, that might go too far out that it wouldn't print. So that's actually an issue. So these are the kind of things you want to keep in mind when you're printing.
So even though it's not, maybe it's a millimeter.
It's not much, but just because gravity and all, because it just goes straight out, it might be too far out that the printer would.
Connect it to that.
If you were to scale it down, and it was very small, then you could actually just like poke a little bit of plastic out and it would stick. But I can't really tell. It looks like it might be too far out. So there's various issues that you might encounter.
And just because it's on Thingiverse doesn't necessarily mean.
Most of the models on Thingiverse are printable. So maybe this is printable if they upload it like that. But because Thingiverse is meant for people to 3D print off of by downloading the models, generally they've taken that into account. And actually, if you on Thingiverse, if you find a model, usually people will have instructions. So if you scroll down,
comments
in the description or after the description, they also have instructions. So a lot of the time, this looks like it's instructions for actually building it, but most of the time they'll say whether you need like a certain amount of infill or certain layer heights, stuff like that. A lot of the time people will specify that. So in this case, they might have specified that you need support. Obviously, this isn't the same model as the one I'm looking at now, but for that model, they might have specified you need support if they know that's the case. So that's something to keep in mind. Next are these 2 boxes. So you always want to keep them checked, and I'll just explain what they are briefly. So G-code, although I don't have any generated right now, G-code is, like I said, all those coordinates, but also at the beginning of every print, there's commands that say like run safety checks or heat the extruder, stuff like that. And that's like by default, that's what's automatically generated. If you were to not check that box, then it wouldn't be generated. Then you'd have to like write it in yourself. And it's not even like a programming language you can really learn. It's kind of just like letters and numbers to like specify a specific command.
So anyways, just check it off.
You want to keep this checked. And then this is also which allows the specific control of like things like how fast the plastic's extruded, which is essentially layer height, and then things like how fast the extruder moves back and forth, which I'll explain right now. So object infill is...
So just to back
yeah.
up, use print-o-matic stepper extruders only. Is that what this is?
Yeah, the stepper extruders are like these motors over here. That's what controls like all these fine it's just like like the more specific controls, and you'll see if like I uncheck this, I lose my controls.
Okay.
Yeah. So anyways, object infill is with solid models. Since the model is made solid, instead of printing it completely solid, since that would take way too much time, when it detects that a model is solid, it allows you to pick how solid you want it to be. And in fact, let me just grab some models and examples, and I'll grab some other things as well.
It's a fairly clean software for the complexity of it.
It is.
Like it's not crazy deep with menus or anything.
No.
So it's kind of nice.
You'll be fine.
Yeah.
The harder part is learning the design.
Yeah, I can imagine. Yeah.
Okay. So for object infill, you can see here, this is an example of object infill. So I think this was a pig of some sorts. It was a solid model. So when Replicator G sees that it's a solid model, instead of completely filling it with plastic, since that would take so much time in plastic, right, you can specify how solid you want it to be. So like this, I think is about 10%. So you can see is when you specify whatever number, it'll generate this honeycomb structure on the inside. So it's relatively hollow, it's pretty light, and it gives us some structural integrity because the honeycomb structure is pretty strong. This just means that you can save a lot of time in plastic, but it's also not as weak as if it were like completely hollow, because then you can kind of just puncture a hole, or you could just
it's
squeeze
translucent.
it, right?
Yeah, it's so thin.
So I mean, for example, if you were to do 100% infill, it would look like this, where the entire thing is just completely filled with plastic. So you can also feel how dense it is. This is much heavier than things with infill.
Yeah. Just kind of a loose stuff.
Right, exactly. Yeah. So, I mean, it's up to you, really. If you need something that can take a hit, then you would use 100% infill because this is very, very solid. And maybe if you just want it to be heavier, like for example, this is a phone stand, and you might actually want this to be 100% infill. If it's holding a phone, so it doesn't move around much.
More stable.
Yeah, exactly. So yeah, and then 0% info would also just be completely hollow. So once again, it's up to you how much time you have and how strong you want it to be.
Yeah.
Right.
So is there a standard?
Generally, I just go around 10% if I just want some infill, so that it's not like completely hollow. But I don't go much higher because it usually just won't add much to it. It'll just add more time. But unless it's really taking a hit, then 10% is fine. You can even go 5%. I just don't like the feel of hollow prints because they'll make that clinking sound if it's hollow plastic. But it's really up to you. Next is layer height. So, I mean, as you can see, each model is printed with layers stacked on layers, right? That's just the way 3D printing works. But you can actually specify how thick each layer is. So on these printers here, on the Replicator 2s, you can actually, the lowest layer height you can go to is 0.1 millimeters, so that's 100 microns. And then on the Replicator 1 over there, you can go to 0.2 millimeters, which is the lowest on those printers. And pretty much with this controls,
just to back up, will that default to the lowest?
This is actually a default to whatever setting was on last. So whoever set this last had these settings on.
So not necessarily capability of the printer.
Right. Yeah. So I mean, I could technically type in 0.2 on the Replicator 1, or sorry, 0.1 on the Replicator 1, and it won't necessarily be able to achieve it. I can type it in though, and it would try its best, but it can't actually achieve that resolution. So yeah, layer height essentially controls the resolution of the print, so it's how good it looks. So if you have
finer.
if you have more layers, then it's harder to distinguish one layer from another.
Right.
So it looks more like one fluid object. But if you have thicker layers, then you can clearly see the difference in layers, and you can see that it's you'll just be able to tell. So you can see here, you can see these lines that go through it. Not like the small lines, but you can see larger lines where This isn't perfectly rounded, so it's actually made out of like many polygons. So it's like a flat shape that rounds up. And then if you had more layers, it would be harder to see that. But
So like on here, that.
right, yeah. So I mean, because the way the printer works, that's kind of like that'll happen anyways. So
Right.
you can feel the layers, but at a glance, like from here.
But those steps would be larger steps if they were thicker.
Yeah, if they were thicker, they'd be larger
Okay.
steps, exactly. And it's just easier to see that way. So it's about how good you want it to look. This also affects print time a lot because let's say you have 0.1 millimeter layers. If you have a 0.2 millimeter layer, it'll take 2.1s to make up 1.2 millimeter layer. I'm
Gotcha.
using too many numbers in there, but
Okay.
so it would be essentially like twice the
Twice the
time
amount
to
of
print
time.
because there's twice the amount of layers for the original one layer. There's 2 layers for each one, so yeah, it takes a lot longer to print. But it is very nice quality, so if you want something to look good, it's actually worth the time in some cases, but it's really up to you. So just keep that in mind. A lot of these settings, like I said, have an impact on print time. It's mostly about how fast you want it to print. So next is number of shells. This is one of the hardest ones to explain because number of shells is essentially just like if you would have a circle, it's just kind of like this layering on top. It's like someone described this very well before. They said it's kind of like frosting. I think that's a good way to explain it. Like frosting on a cake, it just adds this extra layer of thickness to the outside. The numbers you want to use, this is just like general consensus because they don't give units for this, but it would be between 1 and 12. Or you can do 0, which is no extra shells. Normally I actually go with 0 because I don't, like most models, since they're made for printing, they don't need any extra thickness, so you don't really need to add any extra shells.
Yeah.
0 is just fine because that's the way it was made. But the way it works is just, like I said, it adds that extra thickness to the outside, and then it'll fill it in with plastic. I've actually run into some problems in the past where I've used an extra shell and the model was small enough that it actually didn't
Filled in some spaces.
well, actually, it didn't fill it in. So I had this like really thin shell of plastic on the outside of my model, but there was a gap between that and the model itself. So then it leaves this like flexible plastic on the outside, which doesn't really add to
Yeah.
it was so I try to not use it if I don't need to. And generally, it shouldn't be necessary if the model's modeled well,
designed.
anyways.
Yeah.
Right. So that's number of shells. Next is feed rate. This is actually pretty important. So feed rate is how fast your extruder here moves on the conveyor. So it can move along the x-axis and along the y-axis. Generally, you don't want to hit 100 millimeters a second. I think that's pretty fast. Although I would say that's like the upper threshold of what you want to go to. Normally I say 90, but maybe 100 if you really need to. Technically, the fastest you can go is 120. But you never want to go that fast because what happens is as your print speeds up, you can actually see it here a little bit. You get these really, like every layer comes out very rough. And that's because as the plastic
dried.
yeah, because well, as the extruder is moving so quickly, it'll it'll stretch the plastic, but as the plastic cools, because it's been stretched, you've got these like thin ridges that are popping up, and then they harden like that, and that's that's how you feel these ridges. But if the printer were to move slowly, then the plastic isn't stretched and pulled into thin strands, so then it settles as like one piece of plastic instead of these like rough edges. So then you have a much smoother print, which is like this, where you can actually see it shine because the layers go together so smoothly. You can actually feel it. It's incredibly smooth. This is like one of my favorite prints because I actually printed at 45 millimeters a second, which is why it came out so smoothly. Whereas if you were to print even at 70 millimeters a second, it would still come out rough. Maybe not as rough, but it'll still come out rough like that. So once again, this is a trade-off between quality and speed, which is what most things are. So for this quality print, I did 45 millimeters a second, like I just said, and then generally 60 and higher will yield a rougher result, but again, it takes less time because your extruder is just physically moving faster.
Right.
So that's feed rate. That's really important to keep in mind.
All right.
Next is travel feed rate. So travel feed rate is how fast your extruder moves when it's not extruding plastic. And because it's not extruding plastic, normally you can just set it to 150, which is the fastest speed. You'll actually see it when it's moving over here for homing. Once it homes and it starts its print, you'll see it just zips along pretty quickly, but it doesn't really affect the print. So I usually just set it at 150. So yeah. Next is print temperature. This is just the temperature of the extruder when you're printing. So as long as you're anywhere between 220 and 240, anywhere where the plastic will melt, that's good. Any lower than 220, and your plastic won't really. I mean, if you go too low or too too far below 220, then your plastic isn't going to melt. Then your plastic is still solid in the extruder, and then when the motor starts running, it won't be able to push the plastic through because it's so solid, and then you'll burn out the motors, and then it's not going to print as well. So you want to make sure it's at least 220. You don't need to go any higher than 240 because at that point, the plastic is melted. So what will printing any higher do?
Yeah.
Right. So
when I click that checkbox, are these filled with defaults?
No, this is just the settings that the last person used. No,
Okay.
it just
Right.
remembers your settings, right? And they're also defaults, which I'll talk about. Although there's not much to say about them, but they're default settings you can use.
So you say 0 shells. So.
Oh yeah, so I would do 0 for this. I just forgot to change it. I mean, I'm just demonstrating, so.
Gotcha.
Yeah, for this print, 5% would make sense because it's like a full cylinder. You wouldn't want that to be completely filled. Point to layer height, unless you want this to be looking really good, then you could do 0.1. Feed rate, it looks like it's actually supposed to mesh with something. I don't remember what this model is, but maybe we want to go slower, so it's a cleaner cylinder.
It's a moving part.
Right, maybe something like that. So those are the things you want to keep in mind. Next is filament diameter. So we have varying diameters of the filaments. So depending on whether it's PLA or ABS, some of them are 1.8 or 1.75 millimeters in diameter. So you just want to change it according to the thickness of the filament. Normally it's really important when you have 3 millimeter filaments versus 1.8, because some of those do exist. We don't have any here. We might get some, I don't know. But that's going to be really important. But you should still change it just because it's a quick change, and it might improve your print quality just a little bit, because it's about like the volume of plastic that's coming out of the extruder.
Okay. So I would look.
That's that. Yeah. So on the,
side.
I'll show everybody. If you get a roll here. So it's. You just flip it over and find where it is. But if you actually look at the label here, it'll say 1.75. It'll say PLA or ABS. But you just want to look for that number, and then you'll know what the filament diameter is. So, thank you.
Only PLA goes on this printer.
Right, and only PLA goes on this printer. I'll just say that. So next is nozzle diameter. This is just 0.4 for every printer because the nozzles are actually all the same for all the machines, and it'll always stay the same. So just make sure that's 0.4, and you'll be fine. Next are the defaults, like I mentioned earlier. This will give you some default settings. I don't suggest anyone use these because when you're printing something, you generally know what it's for, and these settings don't know what your model's for, so you could probably save a lot of time depending on what it is. And for example, if I knew this was a moving part, I might want, let's say, lower feed rate so that it comes out looking nicer, so that it meshes better. Things like that, or you might just want higher resolution so it looks nicer. So that's why I say you shouldn't use default settings, because usually you know better, and you can actually save yourself a lot more time if you just use your own settings to cater to the specific model and the purpose of the model. So after you get all your settings done, you're ready to generate G-code. So all you need to do is hit this button here. You'll see this warning. So let me just explain this warning. Because we're printing at speeds that are considered accelerated, so anything above 40 is considered accelerated, it tells me that I need to turn on a setting on the printer, which is called accelerate, but it's always on all the printers, so you don't need to worry about this. And I think in the other video I've covered how to turn that setting on, or I've showed the where that setting is. So it should always be on, so you don't really need to worry. So you can hit OK. And then you'll see this box pop up. There's just like a progress bar, so it'll tell you how much longer until it's done generating G-code. This might take a while depending on how fast your computer is. If you want to bring in your own laptop, you're free to do so. Might be able to generate faster, although these computers aren't that slow. So anyways, you just have to wait. That's the bottom line. Once it's done generating G-code, you'll see this box disappear. And then in the console down here, you'll see it say load file 3 times for different, I think it might be the same file path. So you'll see something like /users/makerspace, like a file path. But anyways, yeah, you just have to wait for this. Once this disappears though, in order to print, you would hit this button here, which is build. And then as long as you're connected to the printer and you hit build, it'll just start printing.
And so it knows to print from the. Do I have to navigate to this
G-code?
file?
No. So if you generate the G-code, you'll see
Sort
a
of
tab
sitting
here.
in the on-deck circle there.
You'll see a tab open here that's called G-code, and that'll be the G-code that you just generated, like the most recent one. And actually, if you close Replicator G and open it again, it'll open the last G-code you had open.
Generated.
So then you can always just print it out like right away.
Okay.
Also, when it generates G-code, it gets saved to whichever directory you download it to. So if I go to Thingiverse downloads, you can see all these. Actually, these are things, but like you can see the STL and then also generate the G-code and put it right above it, because this is alphabetically sorted.
Right.
But so you can always go back and find the G-code instead of generating G-code every time. You could just, if you know you've generated it already, you can just find it, open that, and then if you were to open G-code, it won't actually show you the model because you would actually have to open the STL to see the model. But if you open the G-code, it'll open the code. You can view it and then you can just build it from there. So that's actually pretty nice. And then
The code is just going to be like.
just coordinates.
Code.
I can show you once this finishes generating.
Okay.
Actually, instead of waiting for it, because this might take some time, I'll just cancel
open
it
one that's-
and I'll open one that's already existing. So when I open G-code, here's the G-code. You can see that actually, this one opened the model. Good. Whoops. I mean, sometimes if the model gets moved, you won't see it. Well, that's actually
Isn't that cool? I
That's a-
downloaded that one.
pretty cool model. And it's got like a little animal inside. Anyways, so yeah, here's the G-code. Yeah, dinosaur. Here's the G-code. It's like, so you can see at the beginning, it's just commands that say, you can see like here, where is it? Where is it? Here you go. This just says set the extruder temperature to 220. So you can actually modify the G-code directly if you want the temperatures to be different. I've done this in the past when people accidentally set the print temperature to 180, which didn't actually melt the plastic.
can
So
go in there and fix it.
instead of regenerating, you can just edit the G-code and change the temperature that way. But anyways, so once you get the G-code open, you can just build this since it's the G-code. So you can just hit build and it'll print it. And what I said about the coordinates, if you look here, it's just like a bunch of coordinates, literally just X, Y, and Z points. So that's the way G-code works. Next, I guess I can talk about the control panel since this is software based. In the control panel, what you can do is just control the motor, so you can move the motor around and you can also move the platform around. So if you have continuous job run, what this means is if I hold down one of these buttons, your extruder will continue moving for as long as you hold the button down.
Okay.
And so you can see here I can move my extruder left and right, forwards and backwards, and then I can move my platform up and down as well. So this could be useful if you just finished a print and you just want to get everything out of the way. Sometimes if you're in control panel or if like you finish printing, sometimes the motors lock themselves, or when I say lock, it means they're just waiting for computer input, so you can't push it yourself, which means like the motors are active. If the motors aren't active, then you can actually manually push the extruders around. I wouldn't suggest you manually push the platform down just because since it's on springs for calibration, you might uncalibrate it a little by putting too much pressure on it, but you can move this around manually. Right now I can't because I'm in control panel, so it won't let me, but you can see here that I can move everything around. This is actually, you can adjust the speed because it's moving a little fast, so I can lower the speeds, and now you can see it's moving a little slower. So that's how you use jog controls. There's a few uses other than maybe just like moving things out of the way to get to a print. I mean, you can just use it however you need to use it. So that's that. Next is the extruder motor control. So this is more of the second training where you learn how to change filament, but I'll just discuss what this is down here. So in order to heat the extruders, you can actually just type in a target temperature here. So you can see currently it's at 25 degrees Celsius. In order to heat it, you can just tell it which temperature you want. So for example, if I want 230 degrees Celsius, I can type in the number and hit enter. Then you'll see on this graph here, actually, oh, there you go. Here's the target temperature. It's just graphing the target temperature. And then the current temperature, it'll graph that as well. And you can see it starts to rise. Because it's heating my extruders. And also, if you notice here, the color of the LEDs changed.
Yeah.
That's also something I mentioned in the second training, but there's a setting that called heat LEDs that lets you change the color of the LEDs whenever you're heating it, and then it'll go back to normal once it's done heating. It's just to give you like a
visual.
Yeah, visual. So at a
indication.
quick glance, you can see like it's
So
heating
heating.
or it's done heating, stuff like that. And then just remember that if you're going to change filament, which is once again the second training, just make sure it's heated beforehand. So you can do that through the onboard menu, or you can do that through the software where you can just type in the number and hit enter. So just make sure it's at 220 before you start running the motors, because otherwise the plastic might still be solid. So that's that. That's a control panel. I think that might be everything. Yeah, and that you need to know in terms of software. That's for Replicator G. I'll talk about MakerWare really fast because MakerWare is the alternative to Replicator G. It's still in beta testing, so MakerWare hasn't officially published the software yet. They're still testing it, but they've actually worked out most of the bugs, so we've started to discuss it more, like talk about it and introduce it to people, because before it had many problems where I couldn't actually print anything with it, but now it's a lot better. So this actually, it's pretty similar to Replicator G. Instead of everything on the right side like you see here, you see the main feature is the view window, unlike here where it's kind of just like a side window. So you can see, yeah, here's your platform. Same as before, same kind of concept. You have the same tools, so it's like view, move, rotate, mirror, scale. Although there's no mirror, they removed mirror. But they didn't remove it because they didn't develop Replicator G, but they just decided not to have it. You can see right now it's saying no object selected. In order to use MakerWare, first you need to add an object, so you can just find an STL and add it. So if I do this, this object is off the platform. So what it's saying here is when it sees that I'm trying to import the model, it's floating in space. So it's saying, do you want to put it on the platform? I'll say yes. It moves on the platform, so now my alligator is on the platform. And now that I have this, I can select the model. So you can actually add multiple objects at the same time. So I can like add another STL of Bill. So move the platform. Here's Mr. Derry. So now I have two objects, so I can select like between the two and move them independently. This is also really nice because unlike on Replicator G, I can load multiple models and print them at the same time. So I could generate the G code for this entire thing and then
As
print
one
both of
object.
them. Yeah. So you can also just duplicate the alligators by adding them multiple times and print multiple copies at the same time. Whereas on Replicator G, you would need to print it and then restart the print and restart the print to make multiple copies. Another nice thing is it gives you like the distance that it moves specifically, so it actually reads out the numbers to you, which means if you were interested in having precise movements, then you could actually accomplish that here. Whereas on Replicator G, you actually don't get a sense of how far it's moved unless you pay attention to the increments of
originally,
movement. Right. So that's that, which is very nice. It's actually really nice that you get that level of control. And then next is rotate. So this is just like on Replicator G where you get those 90-degree intervals, but once again you get more control where you can actually specify specific degrees of movement. So I can actually tell it to move 4 degrees and on whichever axis, which actually lets me correct, like sometimes if a model comes in at a strange angle, I can actually correct it manually now because I can specify like specific angle I want it to move. So once again, that's a very nice feature. Next is scale. Once again, this is also really nice. If I know I want my alligator to be 60 millimeters on the x-axis, I can type in 60, and because I have uniform scaling on, when I hit enter, it scales everything up to match.
constrained.
Right.
Yeah.
So it's like the proportions are proper. Whereas if I didn't have this on, it would just scale that up.
Stretch it.
Yeah, only the X up, and it would be unproportional. And you still have that same button for correcting
Oh,
like
inches
unit
to
issues
millimeter.
where if you would export in properly, and then you also have the same feature where it's scale build to platform. So it keeps all those nice settings from Replicator G, but it also adds extra functionality. And then if you were to print, you would go to make, and actually because Replicator G is currently using it, I
Right,
don't
you
have
can't.
the background service. If I quit Replicator G, I should be able to use this. Actually, I would also need to.
Clear the.
If I restart the background service, it'll reconnect to the printer. So if I just wait, so now I'm connected. Now I can go to make. Okay, so now this is actually a lot like the Replicator G generate G-code interface. So they actually added these extra settings here. I can just tell it what resolution I want, and then it'll load some defaults, and then from there you can edit the settings here for your like personal settings. But it's nice because it gets you like a little closer.
There.
If you know you want, if you know you want it to look good, it'll just give you some general settings, and you can tweak it. So like for high resolution, it goes to the lowest layer height, and then they also just spread, instead of having everything on one menu, they spread it over a few tabs. So speed is now on its own tab, and then quality is its own tab here. And then if you want to print it now, you can just hit make it now and then print it, which will just build it off of MakerWare. You can also export it as G-code. So you can now just hit export, and then it'll create its own G-code, and then
You can come back a different day.
and then print it. So it has both functions. I mean, so does Replicator G. And then also you want to make sure you have the right printer selected, just like the slicing profiles on Replicator G. So so let's say use MakerWare, and then use it and make it now or export, and it should build it. It's also a lot faster at generating G-code. I guess they used newer algorithms or a different slicer to make the G-code, so that's nicer in that regard as well. It also just looks more elegant because it has this nice
View.
to it. Yeah.
So are people beginning to use this now that it's less?
I see it used a lot more commonly. I mean, it's nice that they finally worked out the bugs, so now we can actually use it. Because before you would have problems where you would go to print it, and it would give a loading bar for it printing, and then it wouldn't actually print it, but then that loading bar would continue saying it's printing. You could start another build in the meantime, and you could eventually have like 10 builds going at once, but nothing would actually be happening. So there are bugs like that. So now this is actually, I prefer using this. Although I still, I don't have a personal preference. It looks nicer, it's functions nicer, but I don't mind. They both work just as well. So that's up to the user. And I mean, I guess that's everything for MakerWare. So I'll just close without saving. And I guess that should be everything software-wise that we need to cover. So
Good.
Lesson 1.